name is Jacint. I usually use only my first name because I got the weird one. I worked for NetApp as a systems engineer. So I worked for NetApp as a systems engineer for Southeastern Europe, which Romania is part of. This is my fourth IT Congress. I really enjoy this conference because it's kept as a technical one with a lot of people. In the region, it's pretty much one of the biggest IT conference. So I really like to come here every year. In this session, by the way, thank you for coming to this session. I really appreciate it. In this section, I'm going to talk about Flash in general. So I will talk about hybrid Flash and all Flash. And Flash is an interesting technology. In storage, we don't have a lot of times when a consumer technology drives the enterprise. So usually storage business is very close. Storage business is usually driven by enterprise people. And the interesting thing about Flash is generally speaking consumer product. So it's a consumer technology. Originally, Flash has been designed for consumers. So you got Flash in your phone, you got Flash in your laptop, you got Flash. Even maybe my Frigidaire have Flash today. But Flash, generally speaking, a consumer technology, not an enterprise technology. And the enterprise technology started to adopt Flash. So generally speaking, NetApp does Flash for forever, but using Flash for primary storage is like 6 years now. Very important to understand with us that we have platforms where we are using Flash for a lot longer time, but I'm now talking about hybrid Flash and all Flash systems. So we have roughly 180 petabytes Flash shipped till today. And I know patents are not good because patents are horrible and IT is driven by patents and patents are closed. But we have over 200 patents on Flash. So as we figure out new technologies, as we drive new technologies, we need to protect those technologies with patents, and that's what we have, over 200 of those. And we have roughly 75,000 hybrid systems and 4,000 all-flash systems shipped till today. But that's not a small number. What's the reason for Flash? The reason for Flash is we have. So if you look at the compute side of the IT, we have newer and newer CPUs, and obviously the newer and newer CPUs will demand faster and faster backend storages. So that's number one. Obviously, the newer and newer CPUs are used by a newer software edition. So if you look at Oracle databases today, if you look at SQL today, if you look at SAP today, they demand more and more performance. And generally speaking, people would be comfortable to use older versions of software, but obviously older versions of software go end of life. So if you look at SQL 2005 is end of life, so you cannot use it anymore. And when you upgrade, you probably will go to 2014, and 2014 will require a lot more performance than what you were comfortable with 2005. And the third thing is virtualization. So even if you don't talk about VDI, virtualization will drive the utilization higher. So the reason of virtualization is because you want to use more stuff for the same amount of physical servers. And if you have the same storage system behind, then the utilization will grow up. And especially if you have technologies like we have duplication for primary storages, then you will need less and less capacity because duplication will save you a lot. But you will need the same or more performance. So we need to figure out new technologies how to help this. So what can Flash do? So number one, Flash can be cheap. Flash can save you a lot of money, which is an interesting thing because Flash is expensive. So how I can use an expensive technology to save money. That's number one. Flash can deliver higher performance. So Flash is fast. That's why we love Flash. If it would not be fast, we probably would not care at all. And the third thing is, it has a very good effect on the environment. So if you look at power consumption, if you look at cooling, Flash is a lot better than spinning drives. So there are interesting companies out there. For example, Apple. Apple said that, okay, from now on, we are only going to use Flash. And for a long time, I thought that they are using only Flash because they need the performance. And that's not actually the case. So Apple is extremely dedicated to decrease the effect of the manufacturing, what it has effect on the environment. And they said that, okay, if we are using Flash, then we will have we will be able to deliver a lot more green operations, green IT. So pretty much the same as for standard storage systems. There's no one size fits all. So I cannot tell you. So if you came here with the idea that, okay, I came to this session, there will be this guy there and he will tell me which Flash to use, I'm sorry, I will disappoint you because there's no one size fits all. So there may be application running at company A, applications running at company B. Those probably will drive different performance requirements, they will drive different capacity requirements, so they will require different capabilities. So let's look at first that why did I say that Flash can be cheap? If I look at what kind of technologies we are using in storage system, obviously we have the traditional hard drives, right? So we have most of the storage systems out today are delivered with standard hard drives. It doesn't really matter, you can have fiber channel, you can have SAS, you can have SATA, all of those are traditional hard drives. They are spinning, they require power, they require cooling, and so on and so on. There is a combination today which is interesting for most of the customers. They are hybrid systems. So hybrid system is definitely something which have something more than one. So hybrid system in a storage perspective is something which has spinning drives, so traditional hard drives, and does have Flash in the same time. And you have some technology in the background where you can use spinning and Flash in the same time and use some technology to use them in a combination. And we have all-flash systems. All-flash systems are a good one. Customers love them because they are extremely fast, and storage admins love them because they are extremely fast. DBAs love them because they are extremely fast. Procurement not necessarily like them because they are not so cheap. And there's the future. So we left this gray part of the picture as the future technology. So what I can tell today, Flash is important. Flash will be our future of storage. We will deliver more and more Flash, that's for sure. But the Flash what we use today, so the SLCs and the MLCs, they are not the future of storage. They are temporary. We are using them now because that's what we have. This is what, let's say, somewhat affordable. This is what you can buy today. But the Flash is replacing extremely faster. Flash is replacing a lot faster than hard drives replaced ever. So TLC is already on the picture. You can call it TLC or 3D Flash. And we are using MLCs and SLCs only for a few years. So the technology is replacing extremely fast. So that's why we have this gray area on the picture. That's for the future. So what these technologies are good for? So if I look at the traditional hard drives, the traditional hard drives are obviously good for getting capacity for some price. So what traditional hard drives will give to you is that you will get the most capacity for the same amount of money. So if you're looking for capacity, let's say backups or archival data or anything which doesn't need any performance, traditional hard drives are the best thing to do. We have all flash. So all flash will deliver the most performance for the same amount of money. I don't think about capacity at all. I'm not interested in capacity. Capacity doesn't count. But if I look at the amount of money I can spend, that all flash will give me the most performance for that amount of money. And there is hybrid between those two, which will be a little bit good for capacity, a little bit good for performance, and somewhat affordable. So that's the mid place between them. Usually the mid place are the ones, right, where you say that, okay, it's not good for that, not good for that, not good for nothing. But in this case, hybrid are, those are reasonable things. So what's the difference between the hybrid and the all-flash arrays? The biggest difference is not in I/O per second. So if you look at storage, if you look at data services, usually there is a number what we are using to describe storage performance, and that number is I/O, so I/O per services, I/O per second. This is a good approach, but if you look at the storage system, the same I/O per second can be delivered with all flash and with hybrid system in the same time. So there will be no difference from that point of view. The biggest difference here is the response time of the storage system. And that's a very important number. The response time of the storage system is very important because that's what actually the application administrators will feel. So if you look at a storage system which doesn't have flash at all, it will be able to deliver performance. Let's pick a number. So let's say 10,000 IOs. This is what I need. So I want to deliver 10,000 IOs because this is what my database needs. If I look at a standard hard drive-based disk system, it will be able to deliver 10,000 IOs. It is doable. You need to select the minimum amount of drives, and you will be able to create a system which can deliver that. If you create a hybrid system, it will be able to deliver 10,000 IOs, no problem. If you build an all-flash system, it will be able to deliver the 10,000 IOs, no problem. So all three will be able to do that. What's the difference? The difference is the configuration. How many drives are using, obviously. The biggest difference between these three will be the response time. If I take the standard hard drive system, when it delivers the 10,000 IOs, it will need at least 10 milliseconds of time. And that is an important number. So you send the package comes back, and the package will need 10 milliseconds. So I can take this number like, if I'm standing here, I walk to the back of the room, I come back, probably it will require for me 10 seconds of time. If I'm running, probably I can do the same in 5 seconds. If I'm super fast, probably I can do it in 2 seconds. I'm not Superman, so I will keep the middle of this. So this is the main difference in storage as well. So you can do it 10 milliseconds. With hybrid, that's not very easy to answer. And with all flash, you can deliver in less than 1 millisecond. So the difference between all disk and all flash is roughly 10 times. And this drives the difference between a hybrid system and an all flash system. So a hybrid system, I said that a hybrid system is a mix of traditional hard drives and all flash. And I said that I have some sort of technology which will be able to do mixing of data within the hard drives and the flash. And this is what this picture shows. If I have an application which works with a hybrid system, I will have data delivered with less than 1 millisecond because I asked for data and I got the answer less than 1 millisecond because the data is coming from flash. And there will be data which is coming from the drives, and those will need at least 8-10 milliseconds to deliver. If I have an all-flash system, it has all flash, so every single response I get will be less than 1 millisecond. That's the idea. So the main difference between a hybrid system and an all-flash system is not the IOPS which is delivered, it will be this thing what you cannot predict. And there's a magic there. So the requirement is usually like this. Do I need to predict everything to be delivered in less than 1 millisecond or not? And that it depends. If you have users who are using file shares, they're opening Excel files, Word files, do some editing, save it back, probably they don't need an all-flash system. If they need to wait for 10 milliseconds instead of 1 millisecond, that's just fine. If you have a credit card transaction, if you have an online reservation system, or if you are in the gambling business, online, milliseconds matter. Milliseconds can matter. If you have a database with a very angry DBA in the back, milliseconds can matter. It depends how loud he is. DBAs can be very, very loud. So let's look at the hybrid arrays first. So what we tend to say is that hybrid arrays are the new normal. So usually customers have a request, have something in mind when they come to us to ask for a quotation for storage. And usually they have some sort of capacity requirement, and they have some sort of performance requirement. And in most of the cases, so I would say like at least 80–90% of the cases today, what we offer is a hybrid array. Because the hybrid array eventually gives the performance of the flash and the capacity of the hard drives. Applications are not magic, and somehow people don't like to do it. Today, hybrid is the new normal. So pretty much every offer we do today, when a customer comes to us with some kind of performance requirements, usually we size a hybrid array. The reason is that they deliver good performance, the SSD prices are low enough, so basically there is not a huge difference between a standard disk array and the hybrid array. So hybrid arrays are affordable today. Let's look at all flash. So far, good? It's okay? Silence is good. Silence either means that you are okay or you are sleeping. So let's look at all flash systems. What can be the good usage of all flash systems? In the slides there are a couple of examples. So there are OLTP, there are VDI, there's analytics, and so on and so on. I usually say it doesn't matter. It's not the application. It's about the predictable performance. If you say that I have my application, it can be any type, it doesn't matter. It doesn't require to be the type what you see on the slide. You can have any type of application. If the application is important for you, if the response time of the application is important, it may need an all-flash system. These are mainly ideas that what kind of applications may need an all-flash system. I tend to use the online gambling because those guys can be crazy. So online, I have a couple of friends working in online gambling systems. For those guys, 1 millisecond or 2 milliseconds is a huge difference. So there are roughly two approaches with all-flash systems. Because roughly there are two approaches with application. And I tend to say that roughly there are two approaches with customers as well. So one of the approaches when when the application likes to handle data. So you have smart type of applications and you have less smart type of applications. There are applications which tends to create data sets in a way that you cannot do anything on the storage system to make it better. Because the application developer figured out that he is the smartest guy on the earth and he drives everything in the application. There are those applications, there's nothing to do with them. So there are applications when on the storage side, you cannot do anything to make the application better. The only thing you can do is to deliver performance. And there are applications where you can work together. So the application can work together with the storage and they can do things better. So from this point of view, we have two types of storage systems in the all-flash space as well. And one of them is targeted for pure performance, doing nothing else, doing no specific functionality, but delivering only the performance. And we have another platform which have, by the way, a lot of extra functionality and it can deliver the performance as well. What's going to be the difference between them? The difference between them will be the price and will be probably the footprint, what you will need in the data center to deliver them. So we have two series, one is called EF and the other called is all-flash FAT. So EF, we have, by the way, we have an EF in the booth. It's a 2-unit system. It has 24 SSDs. That's not a lot of capacity, but usually customers today buy all-flash systems as an island of the IT operations. So usually customers have 2, 3, maybe 4 applications which does require all-flash performance, but probably not everything. So let's look at the E-series point of view. The E-series point of view is an extremely small system. It's designed for performance. It doesn't do anything else. It delivers high performance. So when I say high performance, we are not hiding anything. We are fully transparent. So what we are doing is we take the all-flash systems, we do the official benchmarks, and we publish the benchmark numbers. So if you know what kind of storage benchmarks I'm talking about SPC1, which is probably not the best, but the only reasonable storage benchmark, but still around out there. So you can go to the storageperformance.org and you can search for the NetApp benchmarks, and both of our all-flash arrays are in the top 5. So what an EF system can do, it can deliver the performance, obviously. So the maximum today out of this 2-unit system is 650,000 IOPS, and it's really an ultra low latency. So if you look at all-flash systems, it's not milliseconds anymore. With all-flash systems, we talk about microseconds. So EF systems can deliver performance at 150 microseconds latency. So 1 microsecond is 1/1000 milliseconds. So it's like 1 million times less than 1 second. That's a very short time period. So basically, what we are using EF is we provide EF for customers who have racks and racks and racks of storages, and those storages cannot deliver the performance. And EF does have a very, very reasonable price. The example I can use is we have a customer in Greece. They had an enterprise storage system, and the storage system was not able to deliver the performance, and they had billing issues. And for the billing issues, they requested an expansion of the storage system, and they got a price offer from the storage vendor, and it was extremely expensive. So we gave them an all-flash system for a fraction of the price. It was 2-unit, so it's very easy to put it into your data center, and basically it fixed pretty much all of the issues they had. We give them in a proof of concept, so we give them that, okay, here's the box, try it, if you like, buy it. So they bought the proof of concept and they bought another one. So today they have 2 all-flash systems.
Say the price.
Say
the price.
And the capacity.
We have test units available. So if you're interested, you can get one. I'm doing something wrong. Excuse me, what was the question? I'm not sure I understand you. So, you mean need less power or? Yeah, less quality. Okay. I will have a slide about the failures. I will have a dedicated slide. So it's an excellent question. So there are good questions and there are excellent questions. The good questions are the one I can answer, and the excellent questions is the one which I have a slide for. So I will have a slide for that. So all-flash. So the other all-flash system, what we have is a little bit different. It's called all-flash files. It's a different platform. It has a lot more service. It's a little bit more complex, and you can do a lot of stuff with that. So all-flash files can be delivered as a standalone system standard, two controller, high availability, blah blah. Pretty much similar architecture what you would look at today as a storage. You can also scale out. So if you say that okay, I bought an all-flash system, it's not enough, I want to have another one, you can scale out the all-flash performance and you can get even more all-flash. And the real cool thing about all-flash files is that you can mix all-flash with hybrid systems. So you can build one single storage system which have all-flash portion of it and it has hybrid portion of it, and you can easily move data between the hybrid, the standard drives and the all-flash portion. So imagine that you run your database which sometimes need more performance, sometimes need less performance, and you can easily move the data between the all-flash and the hybrid part of the system. It also means that if you have a combination of all-flash and hybrid, then you can replicate from an all-flash system to a hybrid system or for a disk-only system. Because most of our customers are interested to have disaster recovery capabilities. And if you have an all-flash system, maybe it's not a good idea to buy another all-flash system to have a DR capabilities, because once in a year maybe you switch over, or once in a lifetime you are going to have a DR. So most of the customers we talk to, they say that, okay, I want to buy an all-flash system because I need the performance for my primary applications, but if I have a disaster, I'm not sure that performance is my number one problem. Maybe performance is less important because I still can run my business operations. If I get a little bit less performance, I eventually don't care. So basically from these considerations you can replicate and you can do DR from an all-flash system to a hybrid or a standard disk-based system. So this is the answer of the question. So a couple of years ago there was a rumor about SSDs, that SSDs wear out and SSDs has a lot less lifespan and so on. In fact, we cannot drive enough to an SSD drive to wear it out. That's the fact. This is what we learned. We saw an extreme amount of SSDs. So you saw the amount of flash we shipped, and we don't see SSDs failing a lot. So therefore, we say that, okay, if you buy either hybrid or all-flash systems for us, we pretty much give the same warranty warranty capabilities what we give with spinning drives. Which means that basically we will say that if you have a wearing out drive, we will replace the drive in warranty. It doesn't matter what. So if you have a drive which is wearing out, we don't care. We will replace it in the warranty conditions. So in both cases, EF and all-flash files, we have the internal mechanism to monitor the drives, how they're wearing out, how the capabilities of the drives is behaving, and if it's getting close to the end of life, we simply predictively replace the drive and ship you a new one in warranty. So currently we have 3 years by default, and you can extend it to 5 years. We are looking at how we can provide 7 years of warranty to customers. So I was actually lying to you, sorry for that. So I said we have 2 platforms for all flash. That's not really true because we have actually 3, but I would say it's 2.5. 2.5 because we have one platform which is not shipping. It's for the future, so we are actively developing it, but you cannot buy it. Actually, you can, but you cannot put it into production. So we sell this thing if you want to test what the future brings, but usually customers are not interested to buy tests. So basically with FlashRay, this is the name of the product. With FlashRay, we are planning to deliver systems when the next generation flash, the next generation solid state will be available. So FlashRay system is designed for TLC solid state. So TLC is the next generation of the solid state, and FlashRay is designed for this next generation of solid state. It will deliver with similar capabilities as all-flash. So it's going to have deduplication and compression in an inline way, multiple space-saving capabilities, and it will have integration with all flash files, so you will be able to replicate data and move data between the platforms. So with these 2.5 platforms, I'd like to thank you for coming to the session. Unfortunately, I speak too much, so now I don't really have to answer any question. If you have any question, you can find me in the booth. In the NetApp booth, we have an all-flash EF5. I think it's an EF550. You can look at, actually I don't know what the Cisco guys did with the configuration, so I don't know if you can demonstrate performance, but probably we can. So thank you for coming for the session. I really appreciate it.